Hello, grade 9s. In this video, we are going to talk about how to come up with the equation of a linear relation from a description. So up to this point, we've looked at rate of change and initial value. We have found the equation of a relationship from a pattern. We have done it from a table of values. And today we're going to look at the connection between a description and its equation to see if we can find a short way of being able to write an equation just from its description. So up first, we have a carpenter charges $100 starting fee plus $45 per hour. So that means that if you hire a carpenter to do a job, they will charge you $100 kind of just as their beginning fee, and then $45 for every hour they have to work on the project. So up first, it says complete the table of values. So we have hours worked and cost. So for 0 hours, it always seems weird to people to talk about 0 hours because if they didn't work for any hours, why would I pay them? But mathematically, it's just us trying to process the information. So if they don't work any hours, they do at least charge you a $100 starting fee. So it would start at a cost of $100. And then if they work an hour, you have to pay the $100 plus $45 for that 1 hour of work. So 100 plus 45 would be $145. Okay, if they work for 2 hours, you've paid the $100 already. You paid $45 for that first hour of work, and now I need to add on another $45. So I'm going to take that $145 and add on another $45 to get $190. And then if we do 3 hours of work, I have to add on another $45, which would be $235. And for 4 hours of work, we would add on another $45 for that extra hour to get $280. Okay, so some questions. State the initial value. There really should be a period there. The initial value is the 0 term. It's the starting amount. So it should be this part in my table, which is the $100. And then it says calculate the rate of change. So in order to calculate rate of change, we need to first calculate our differences because rate of change is delta y over delta x. So x is always the column on the left-hand side and the y is the column on the right-hand side. Right? Delta x is going to be the differences on the x side. Delta y will be the differences on the y side. So to get from 0 to 1, I added 1. To get from 1 to 2, I added 1. From 2 to 3, we added 1. From 3 to 4, we added 1. On the other side, to get from 100 to 145, I can do that in my head. I see that I added 45. If you're not sure, you do 145, take away 100. All right, 190, take away 145 is 45. 235 take away 190 is 45. And 280 take away 235, not 234, is 45. So the first thing I notice is this definitely is linear. We're going up by the same amount every time. So when I go to do my rate of change, it is 45. This is the delta y. It's on the change on the y side. So that's 45 divided by delta x is going to be the change on my x side. So that's 1. And 45 divided by 1 is 45. Now this does have units. It is $45. Right? Because delta y, it was on the top, so y is dollars, and then per hour. So it's $45 per hour. All right, and then it says state the equation. So we talked about equation yesterday. So the format that we use is y equals my initial value plus my rate of change and then times x. So you can use y and x, or sometimes you might want to pick a letter that you think matches a little bit better. So instead of y, you might want to do c for cost, right? Or instead of x, you might want to do h for hours or n for number of hours. It's up to you. So if you want to do y and x, you're welcome to do y and x. If you want to pick letters that relate a little bit better to the context of the question, you can do that. I think that's what I'm going to do. I'm going to do C for cost equals my initial value, which is $100, plus my rate of change, which is $45 per hour. And we are going to multiply that by the number of hours. So maybe times H. Right? Or I could have done Y equals 100 plus 45X. Okay. Part E says, what connections do you see between the description, so that original line about the carpenter, and my equation? Normally, I would ask you to take a minute and talk to your neighbor about it, but I think we're just going to have to keep moving on here. I noticed the 100 matches the carpenter's starting fee, and the 45 matches how much they're charging per hour. So I see a very direct connection between my equation, right, and the description that they gave me. So I'm going to say, what connection do I see between the description and the equation? So I'm going to say the starting fee is the initial value. Okay, and then what else did I see? The amount they charge per hour is my rate of change. So their hourly rate is the rate of change. What that also tells me, oh, you can't see what I wrote. So I said the starting fee is the initial value. Their hourly rate is the rate of change. So when it asked me for the initial value and the rate of change, I didn't even need to look at the table. I could have just pulled it straight out of that description. All right, last part here says calculate the cost of hiring the carpenter for a job that takes 25 hours. So the nice thing about having an equation is that you can calculate pretty much anything that you want. So that 25 hours, that would be H. H would be 25. We're trying to find hour 25. So I can take my equation, C equals 100 plus 45H, and everywhere I see an H, we could put in the number 25. So I would do 45 times 25. And say that the cost is $100 to start plus 45 times 25 hours. Order of operations says we multiply before we add. So 45 times 25 is 1,125. And then if I add 100 onto that, that gives me 1,225. I would like to write a very short little therefore sentence, so I make that therefore, that triangle of dots. I'm going to say it would cost $125. No, $1,225. Sorry about that. Okay, and then our last part asks us to write an equation given 3 descriptions. So now that I know that the initial value and rate of change I can read directly from my description, I guess I'm just going to try to pick out which one's the initial value, which one's the rate of change, and then just go for it. So it says write an equation for each of the following. Our first one says a 3-meter tall tree grows 0.5 meters every year. So one of these two numbers should be my starting value, and one of them should be the rate of change. So the starting value or the initial value should be that beginning amount, and then the rate of change should be something that's happening more than once. So when I read through this, that 3-meter tall tree, I believe that's the initial value because that's the starting height of the tree. And then the 0.5 meters isn't just happening once. That's how much it's going up by every year, which means that's my rate of change. So when I go to write my equation, I can do y equals, right? I could just do y equals my initial value, 3, and then it's growing. So I would do plus 0.5. I don't include the meters. And then every year, so I could do times x. Or if you wanted, we could try to pick something a little bit, more related to this. So we could say maybe the height of the tree is 3 meters and then plus an additional 0.5 every year. So times y or n or whatever, right? So it doesn't always have to be x and y. You can pick other letters if you think they work better for the equation. Okay, our next one says the height of a 500 centimeter ice sculpture decreases by 4 centimeters every hour. So I think the initial value is 500. That's the starting height of the ice sculpture. And I think the 4 centimeters is my rate of change because that's happening every hour. So if I did it with y, I would say y equals 500. Now it says that it is decreasing. It's made of ice, so it's melting, right? So because it's decreasing and it's getting smaller, I'm not going to add 4 centimeters. I'm going to subtract 4 centimeters and then times the number of hours. Or I could say height h equals 500 minus 4n or 4h. I don't like the idea of having 2 h's. So maybe I would just do 4 times n. All right, last one. A plumber charges an $80 starting fee plus $75 per hour. So that would be y equals $80 to start. I think that's my initial value because that says it's the starting fee. And then plus, so we're getting bigger, they're charging more, $75 per hour. So 75 times x. Or if you wanted, we could do maybe C for cost is 80 plus 75n, where n is the number of hours, something like that. Okay, there are some practice questions for you to try where you try to see if you can write some equations from descriptions. All right, you have a couple of minutes to work on that.